right after. No, it's not your fault. Oh, my.
Should we give people a couple of minutes or should we start? Okay, I guess we can start. Can you hear me?
Yes.
Okay. This is Tcpm. So if you're not interested in TCP, you might have chosen the wrong room. You have three co-chairs here. My name is Michael Tüxen, I'm remote, and in front of you are
Ian Sweat.
Yoshi Nishida.
perfect. Thanks. This is the Note Well. I think you have seen it a lot of times this week, so I won't spend much time on it. It applies to this session. The logistics, the session is being recorded. Thank you to Richard Scheffenegger for taking notes. We have a JavaScript. Yoshi will look at the chat, and if there are any comments, he will make sure that they come to light. One information, if you are writing a document and think TCPM is a venue for it, which might be interested in it, then use TCPM in the name, then it's on our radar. So then type draft, whatever your name is, TCPM, then the subject. This is the agenda for today. We gave you a short update on the working group status. Then we have 4 presentations regarding working group documents. 2 of them have at least been for a while on the working group last call. 2 of them will be in the working group last call sometime in the future. And we have two presentations. One is based on the feedback of the TCP-Yang regarding the TCP-Yang module by Guyan, who is presenting what features are needed from a user perspective. And we have one non-working group document presentation, the TCP AG rate request, an update on that. Are there any should this be changed? Any comments regarding that? So I have seen the presenters, I think. Mahesh is still on the train. He's heading to a hotel, and once the once the presentation is up, he should be in the hotel being online. So that should work. These are the documents on the milestones of the working group. The TCPM AO test vectors has been published since the last IETF. It's RFC 9235, and you might have seen a couple of emails regarding errata. So there's one issue, which means, which is that the TCP checksum is wrong in the example packets when using IPv4 as the network layer. This is for 12 packets, so there are 12 or 16 packets, I think. So that's why you see 16 erratas right now. It's up to the AD to figure out whether to apply them individually or change this stuff to a single errata. That's up to the AD. Whatever is however this is handled best in the tools. Martin, go ahead.
Yeah, it's Martin. I don't want to have an extended debate about this. I think probably the least, I mean, you've already filed the errata, thank you for that. But I think the least aggregate work for everyone is if we just have a single, if you just do the step of filing a single errata for all of them, that's general to the document. Well, let me think. I guess we have to tell the RFC editor. I'm sorry, I'm thinking about this in real time, but I guess we have to tell the RFC editor to make all the changes. So actually, you know what? You filed the 16. I'll just approve them all, and that way the RFC ed has no ambiguity about what they're going to do. So I changed my mind in the middle of my comment. Let's just leave it like it is.
Okay, I mean, if talk to the RFC editor. If they want it in a different way, just drop me a note. I can do that. Okay,
that's a good point. I'll ask them. I'll ask Alice before I get out of here how she wants me to handle it. Thanks.
Okay. RFC 793 BIS, that's the TCP spec, the base spec. It's an auth 48, and there have been a lot of comments from the RFC editor, which have been addressed recently by Wes, and so the document is moving forward. The TCP Yang document is, after working group last call, in the IESG last call, a couple of comments have been raised, and the authors are working on addressing them. We will get a status update here, and also we will have a presentation about potential additional features which some users think would be very useful. So we can then, I think they're maybe suggesting something like another more detailed Yang module. The next two documents are PRR, and the next one is Cubic. The PRR is, we have a presentation on that. It's still in progress. The Cubic one, we will also have a presentation on there. We are past working group last call, but got substantial comments and are still in the phase of discussing them. We will get a status update of that during the discussion. Unfortunately, the person raising the comments couldn't attend this meeting. Hi-Stat++, I marked it as green. I'm the document shepherd, so I read it. I have some editorial formal changes requested. Once that is done, I'll do my shepherd write-up and pass it to the AD. So that's, from a working group perspective, it's done right now. Accurate ECN is also on the list of drafts which will be presented. That's ongoing work. Almost ready for working group last call, I would say. We have generalized ECN, which builds on that, and TCP EDO, which has not had lots of changes because, related to the last meeting. Martin.
Yeah, this is all fine, but just, and I realize things have to be done when they're done, but if at all possible, if it's possible to prioritize accurate ECN and like maybe deliver it to me. Well, I don't know. If it's at all, like if you have two documents in front of you and one of them is accurate ECN, please process accurate ECN first, because the L4S stuff is already kind of going through. So I think it's a little awkward for this to be, significantly behind that. But don't slow, so I hope that guidance made sense. Just if as
do you have any document which you are asking us to delay? Or I mean, give priority.
So like the practical implication of this guidance would be that if, like, say, as a document shepherd, you had two documents and one of them was accurate ECN, that you would work on the shepherd write-up for accurate ECN first. This dilemma may not arise. Like, you may just have a document in front of you and then accurate ECN is the only thing on your plate. And obviously accurate ECN has to be done first, and it's not done. We haven't done the last call. But to the extent that you have, process gates and something is blocking accurate ECN, like I would encourage you to.
I don't think anything is blocking accurate ECN. So I think the thing we are working on is basically is cubic.
Yeah.
And
okay,
so I don't see anything being blocked. So we can start working the last call of accurate ECN whenever we think it's ready. We are not waiting for anything. And Bob is coming and telling us that it's ready.
Yeah, this is Bob Briscoe. Yes, that's true. I just wanted to ask whether we're going to get a working group last call on attempt at it on generalized ECN as well, because that's part of the same set. I didn't. Yeah.
it has to be ready.
Yeah.
So, like, rule number one is it is ready, and I'm not saying like can't stop all work so we all just sit here and focus on ECN, but to the extent that there's a process thing where you're doing one working group last call at a time, or one shepherd write-up at a time, or whatever, if there's an ECN doc in the queue, it would be nice if those were given priority. Does that make sense?
Okay.
Okay, thanks.
Any other comments regarding these issues or any other working group related issue? If that's not the case, then I would suggest we move on to the first presentation. We have 15 minutes spare from our agenda, and if there is, for any of the issues we have fruitful discussion, we are willing to run over the time limit in a certain way, but still trying to make sure that all presentations can be handled. So then I would say Vidi can.
Hi, do you hear me?
Yes, we do. Are you running the slides from your computer?
I'm trying to. I asked to screen share.
You don't need to screen share. You can just do the document.
Sorry, yeah.
The document is uploaded.
Can everybody see the
Yes,
slides?
thank you.
All
Perfect.
right. This is update on revised cubic, and we're aiming to publish it as a proposed standard. So there are some issues that were raised by Marku, and I've been exchanging emails with him regarding some of the issues that I couldn't really figure out from the mailing list, and I'll talk about it in a little bit. Issue one is about the TCP friendly model, and it seems like Marku said that the TCP friendly model used by Cubic is not correct, and he pointed to a paper I think wrote by Bob. Maybe we will take this after I present this and ask for Bob's input on this issue that Marku has raised. The second issue is changing beta from 0.7 to 0.5. It is an interesting thing. I have spoken to many other folks who participate in TCPM, and it seems like the 0.7 to 0.5 is kind of like related to the doubling in the slow start, and when you double it and you see a loss, you halve it, you kind of reach the basically you get 1x times the congestion window, which still means the queues are going to be full even if there won't be a second round of loss. So it's not the best, but it still avoids probably a second round of loss. Having said that, I have also spoken about this to a lot of folks and the authors, and my personal opinion is that changing this at this point is not something we think is the right thing to do, because there is just literally no deployment with 0.5. Not in Linux, not in Apple, not in any stack, quick stack that uses Cubic, and I suppose FreeBSD as well as Microsoft. If anybody has or has been using 0.5, please let us know. But this is something I think we cannot change at this point. Then there was issue number 3, which has been resolved by Neil. This issue was about basically, it's just a bug where we were initially we were saying if the congestion window is over W max, then set alpha cubic to 1, and there was a bug here where it should rather say that the congestion window is higher than the prior congestion window. So Neil has fixed that issue. Thank you, Neil, for that. And I think he also said this issue was fixed in Linux. Issue number 6 was about the implementations that still use congestion window directly during a congestion event to do the reduction. And there's a PR open for this. I think there is just a small edit left in this one, as Marku sent an email about it yesterday, but I think this is something we can resolve. So as I was saying, I did email him to ask what are issue number 4 and 5, and he replied a day ago, so I have not covered that. But I think the issue number 4, if I understand it correctly, he mentioned that 0.5 should also be used when we are in congestion avoidance and not just after slow start. I have my opinion on that, but I would like to hear more from the folks here who have any opinion about how does changing 0.7 to 0.5 impact the congestion avoidance. Last slide. There are open issues and pull requests. Actually, there are no open issues on GitHub, but there are open issues on mailing list. But there are pull requests in GitHub, so if you are interested in reviewing them, please go ahead. We're trying to converge as soon as possible, so please help us to review the pull request and merge into the draft. There is support for publication SPS on mailing list as well as in the last meeting. And then for issue 2, I just noted it here. It's not. It can be considered for future, but not now. That's what we think. That's all I have, but we can go through the queue.
Richard.
So Richard Schaffenegger, just an observation. So I believe none of the current implementations of Cubic are pure just implementing Cubic as it is in this draft. So for the slow start, you will typically always have some kind of high start or more advanced functionality there, with perhaps the notable exception of FreeBSD, but there Cubic is not the default method. So maybe it would be worthwhile. So I would want to say that I agree with your statement here that it would not be advisable to change the recommended beta value at this stage. However, perhaps make a note in the document that pure slow start, as you know, in the past, is maybe not the best ideal situation to determine when to stop slow start when running Cubic. Thank you.
Thank you, Richard. And that's covered in the document.
Hi, Bob Briscoe. I think if you are going to mention anything about 0.5 in the document, and I don't know whether that is needed given the way Richard said that, but if you are, I think there's also potential problems with 0.5 in that you then get more queue variation, so you get more delay variation. And so, you know, that's obviously something, as you say, has not been measured. And if it was, I think you'd find things were worse.
Thank you, Bob.
Yoshi from the floor. This is my individual comment for issue 1. Issue 1 is kind of overshooting issue is slow start, but I think this is the issue for slow start, not the Cubic. Cubic, if we use Cubic, it's more visible compared to Reno. But even Reno, we have an overshooting issue. So I think the problem should be fixed in slow start, not a Cubic. All we can do in Cubic is just tuning. But at this point, I'm not sure if we need to do that.
Putting my chair hat on, if folks could try to add themselves to the queue, even if you're in person, that'd be great. Thanks.
Any more comment? It's okay.
On the chat, Rodney is asking whether you can run high start plus path with Cubic.
Yes, people are running that already. It's also mentioned in the draft.
Yep.
Stuart Cheshire from Apple. So my quick comment is, this is largely documenting what is incredibly prevalent on the internet today. So if somebody wanted to propose a Cubic version 2 with a different beta parameter, that's fine as a proposal that the IETF would discuss, but that is really not the purpose of this. And this is reflecting the reality, as several people have said. The reality has had the benefit, good or bad, of lots and lots of testing. This proposed alternative would take years of study to get to the same level of understanding about how it behaves at large scale.
Okay. Any more comments? And then one thing I would like.
So Rodney, asked on the chat, does that solve the alpha issue of issue 1? I don't know if folks understand the issue 1. Yeah, sorry. So the issue 1 is a little bit complicated. If you read on the mailing list, it might provide some insight, but it's really hard to explain it in short time.
Yeah. Uh, yeah, for issue 1 is alpha model. And so I have some, Mark and I have been a discussion. And then I have some comment, and Mark had some comment. And then we exchange a lot of comment each other. Then right now I have some counter argument, his comment. But probably his counter argument, counter argument. But I will have a counter argument, counter argument, counter argument. So the conclusion is this is not an easy issue. That's a conclusion from this point. And that means in order to settle down this issue, we need more detailed analysis. Otherwise, we cannot settle down the discussion. But at this point, I don't know if we should wait for the conclusion of the discussion. It may take years for detailed analysis. And if our purpose is like publishing the cubic draft in 2025, this is a perfect version of cubic, then we can wait. But this is, I don't know, this is what we want, basically. So if as Charles says, if we want to make a cubic version 2, it's totally fine. We should do it, but not this draft. I think that's the general consensus of the working group. We have analyzed the consensus in the previous meeting, and then we see solid consensus that we are going to publish this draft as a proposed standard. And I don't see any big opposition to change current situation from my point of view. And the one thing I want to emphasize is the cubic draft is not a threat for the internet. If we deploy cubic, there is no congestion collapse happen. Nobody said that. So what we are arguing is if we compare Reno and the cubic, and then cubic might be aggressive. And then some people say it's not too aggressive, it's maybe a little aggressive, but some people say it's drastically aggressive. But this is under discussion. We don't see any conclusion yet. But in order to see the conclusion, we need more analysis. That's the current situation. And then at this point, does people want to wait for detailed analysis of the result, or we want to publish? And then let's discuss about the cubic version 2. Which one people want? That's the point of the discussion, in my understanding. And if people any comment on this one, I would like to hear it. If there is no strong opinion, I think I would like to proceed it.
And I just want to add to what Yoshi said about doing these analyses. These are more research thing at this point and not something that would get to the standards or IETF organization before folks do research on it. So that's a lot of time.
Gary?
Hello. Yeah, I'm going to say again what I said last time at the night. I don't like this position. I think we should have done this spec differently. This spec has been deployed. It's the one we're using. I think we should publish this as a PS. I think we should note down this important discussion we're having now as part of that PS, and we should keep progressing. I don't think we should stop and start evaluating something different to what is actually being deployed.
Martin?
Martin Duke, Google, no hats. To be clear, we're talking about the 0.5 thing on whether we want to see more data there before we move forward. Or did I misunderstand your statement, Yoshi? Which issue are we debating more study of?
One thing is issue 1, cubic, TCP friendly model. And second one is beta for red 0.9 0.7 to 0.5 after slow start. That's another, the two things
Okay.
outstanding.
Well, all right. Well, with issue one, I think the case was made that it was too complicated to discuss in person. And I've not read the email, so I don't know. Issue two, like I think I'm going to concur with the other people that 0.7 is what we deployed, and 0.5 is very researchy, and I think like opening a research topic is not appropriate for this effort.
Yeah, both for research issues.
Yeah, thanks.
Thank you.
So my position as an individual is we should spend some time on discussing the issues, because if it's a mistake in the specification, we can fix it as the one you fixed. If we have something like the .0 versus .5, I would be happy with documenting that people are now using .7 and give a short description why there was a discussion that .5 might be appropriate or the better value or whatever. But it is about documenting what's now being used. Whether that is related to a mistake or not doesn't matter. Richard. Bob, please
just
join
want
the
to
queue.
I just
Richard, go
wanted
ahead.
Not Richard. I just wanted to reiterate. So I think I have said before, I believe we should be documenting in this draft what has been deployed, where we have a lot of experience already. We have known that we haven't corrupted or collapsed the entire internet. And going at this stage to 0.5 and holding this document for an extended period of time, when quite frankly nobody will actually change the beta parameter, I don't know what value that would really bring.
Stuart Cheshire from Apple. I'm kind of repeating my previous comment, but this conversation sounds very strange to me. Taking a step back, it has widely been observed that Cubic, probably the most dominant congestion control in use on the internet, doesn't have an RFC specifying it, and that's a gap we need to fix. If we choose to write an RFC specifying some other fictional protocol that no one uses, we've totally failed in that first goal. One of the goals is document what is, whether we like it or not, the dominant congestion control for the last decade. Let's write it down.
Did
Yeah, sorry,
ahead.
sorry. I wanna just listen to Bob first.
Okay. I just want to switch to issue one. I think issue two is done from my point of view. All I will say is that the model I wrote up was for tail drop and AQM, and I couldn't. AQM is more difficult because it depends on which one it is. And for the AQM model, results we showed yesterday comparing Prague against Cubic and Prague against Reno gave exactly the same results in which over a range of link rates and round trip times. So, you know, I can't believe that no one else has done results like that, but we have results as of now that show that Reno in its TCP friendly mode with an AQM is identical to Cubic within the ability of the human eye to see differences in graphs.
So yes, that's true. And then Bob presented those results yesterday. If somebody wants to look at it, those are available on the ICCRG slides. About this 0.7 to 0.5, I want to reply to Michael about whether it was a mistake. I don't think there's pros and cons to things. Probably in slow start, it is a little bit. Maybe takes 2 rounds to reduce the to basically get below the you know the basically avoid second loss. It's for that, that's the con. And I think probably in slow start there's no pro, but I have to think thoroughly. But in congestion avoidance, it's the queuing delay variation is lower when you use 0.7 because your reduction is smaller. That means um, you don't need as deep buffers as new Reno need. And perhaps it also makes sense for slow start because if you have less deeper buffer, then this slow start will also kind of have low delay variation. So correct me if I'm wrong, but it's not, it's just a mistake. It's about pros and cons, and we can't just look at one side to make a decision. As I said, this is not going to be decided um, right away. It needs some research. Thank you.
Neil?
Yeah, hi, can you hear me?
Yes.
Okay, great. Yeah, I just had a few comments to follow up on a few of the things said recently. I think there was a statement made that probably no one would change the beta value in practice. I would tend to disagree with that. I think there are definite issues with the 0.7 versus 0.5, and I think in the future, I could see, for example, Linux deploying something different, after appropriate research. But I agree with the consensus in the room that for this document, we should document what's deployed already rather than embarking on a research expedition before publishing this. In terms of Bob's remark about the tests recently showing Reno and Cubic look the same, if I recall correctly, those tests were Reno by itself and Cubic by itself, but I don't think we would expect that to show the issue one. I think issue one is about the interaction between Reno and Cubic interacting in the same queue, where the difference is basically the Cubic increases its C wind every other round trip time and is therefore, potentially less likely to see packet loss than Reno is when sharing the same queue. So I think we might need more testing really to understand issue one more deeply. But again, I think that's something that should be put off to the future. We should just document what Cubic does now. And then another question earlier was, what about this 0.7 versus 0.5 in congestion avoidance? And I think, as I think is stated on the email list, I think there is a potential concern with that 0.7 versus 0.5 distinction in congestion avoidance as well, because Cubic can increase its congestion window at up to 1.5x per round trip time. And so if it gets to that rate of increase, then 0.7 is not enough to pull the C wind back down to a level that will actually fit in the network. So I think there is an issue there as well. Again, worth making a long-term research priority and not something in this document. Thanks a lot.
I just wanted to say that the word mistake I was choosing was not, I wanted to, my point was, please document what is out there. And in the case there's a discussion about whether anything else is better or not, or this kind of stuff, we might want to document it, but we don't want to discuss this for years to figure out what is better. So it's about documenting what is out there. Martin.
It was a comeback on what Neil said. So yeah. So Bob Briscoe. Yeah, Neil, there were results of Prague versus Cubic and Prague versus Reno in the same scenario. So you could compare how Reno fights a different congestion control and how Cubic does as well in an AQM. And there are also Cubic with ECN versus Cubic without, and Cubic versus Reno, and so on. So it wasn't just one flow on its own.
Martin Duke, Google, again, no hats. I would like to zoom out a little bit because I think the basic tension here is between documenting what is actually out there and like, you know, because we sort of change control this document, maybe making some fixes and correcting, you know, bugs, so-called bugs and how it is implemented. And I think the right way to think about this is that we have a bunch of Cubic implementers in the room. And I think if in relatively short order, we're able to reach the rough consensus that like, we really should do this with Cubic and, you know, we will probably go back and do this in our implementations, that it would be appropriate to put that in the document. And maybe make a note that some implementations might not do this because, you know, the previous consensus was X, and that's fine. I'm not suggesting we start research projects in this area. That could be a different document. But like, if everyone says, oh, this number, you know, was 4, but it actually should be 5, and that was just a dumb thing, and it's a bug, and we all sort of agree with that, then we can absolutely make changes to what is deployed out there. I hope that's helpful, but I think that's the right principle to apply to these sort of tensions. Thanks.
This is Yoshi from my personal opinion. Yeah, basically I agree to describing the issues, but what I'm wondering is if we, you know, describe the detail of the issue 1 or issue 2, and then I'm afraid that document is getting bigger and complex. So maybe I'm thinking about, you know, we can write about some simple, not simple information document, describe these document detail, and then motivate people to do some more experiment. That might be, you know, from my point of view, might be preferable to describe this specific issue more, you know, specifically detailed. That's what I'm thinking.
Thank you. Thanks for the discussion. Please continue discussing this on the mailing list and get the issues.
I just would like to make sure that our current consensus is publish this document as proposed standard, and then there is no holding back at this point.
Mm-hmm.
If you have any objection of it, this is a good chance to speak up. Okay.
No one does this right now. Okay. Thank you. Then I would suggest we move on to U-turn regarding PRR. Vidi, can you undo the presentation? Can you? Yeah. Will you present? Will you run the slides, U-turn?
Sorry, I thought.
Will you run your slides, or should?
Could you run the slide? Thank you.
I can try to do that. Yeah.
Okay, thanks. Okay, I'm here to present the second revision of the RFC 6937 biz. Please, next slide. So what is RFC 6937? Just to remind people, is the PRR, proportional rate reduction, for TCP congestion control, specifically during fast recovery. Basically, it decides what the C1 and how fast to send during the fast recovery. So it's a kind of mini congestion control. While it's mini, it actually can be used very, very often when a connection is experiencing very frequent losses. It was published in 2013 as an experimental and only implemented by Linux at that time, without rack and POP. So it uses the previous RC 3517, the conservative stack-based recovery at that time. So over 9 years, we have done some large experiments through real deployments and revised the algorithm several times. And it's now default in several stacks here on Linux. BSD, Netflix rack stack, and Windows. And I want to emphasize one thing is that this sort of fast recovery congestion control is actually the default no matter what congestion control module you use in Linux, except BBR. But BBR has a lot of this shared sort of principle or algorithm like RC6937 as well. So I think a year ago, I think our group decided that this should move to standard now, given the large implementation, expand pose, and the experience that we have. Next slide, please. So let's talk about the most important improvement of the original algorithm. That is when the in-flight drops below SS thresh, right? So for example, if your C1 was 20 and you use Reno and your SS thresh during congestion control is lower to 10, but your in-flight has dropped to say 3 or 2, like below that 10 number. This is when the original algorithm asks you to handpick 2 different algorithms. One is more aggressive, the other is more conservative, but it comes with pros and cons. So let's look at that. The aggressive version is you, during that time, you slow start, right? Since your C1 is below SS thresh. Obvious upside is that it's a log-n recovery because it's slow starting. The downside is that if during this fast recovery, the buffer remains very full, it's not just a single burst drop, or you are going through a policer which runs out of tokens. That's why it's essentially dropping any excess rate that you send it through that policer. Then this could result in terrible losses because literally you are pouring gas to fire. So it will be like keep repeating shelling, sense, trying to ramp up at twice the speed that the ring is draining, and those just keep getting lost. Very easily, if you don't have rack, that results in repeated timeout because you run out of any app clocking. But on the other side, if you pick the conservative one, basically it's a strict packet conservation. When you get a packet sacked, you send one more into it. Obvious downside, linear recovery time, and packet losses and round trips. For large congestion window, this is terrible. But the upside is that since you are just sending exactly as the link draining rate of your connection, you are less subject to further losses in this case. So the improvement really is to dynamically pick this based on the situation, that what the next act or the most recent act indicates. By default, we want to be conservative. But if the last act indicates that, hey, the repair is in good progress, meaning that the send UNA is advancing, that means your last retransmit has been delivered successfully, right? And more importantly, since send UNA is advancing, that means receiver application is making progress as well, that he can read more. And also this act does not further indicate packet losses, meaning that things looking good, making progress, and there's no further losses, then we'll do slow start. And it has been shown that this simple technique is very useful to make it dynamic. Next slide, please. Another smaller issue is that the original one doesn't really define non-sack case. What do you really do? So here we apply some very simple technique that was actually implemented, but just didn't get documented, which is if the act is a due back, right? Without sack, all you get is due back. And you simply just assume that, one packet has been acknowledged or delivered. Of course, this comes with that famous caveats that Neil found years ago that, hey, what if I just send a 2 back every byte I receive? So here we add some more protection, meaning that we assume that you cannot act more than whatever that has been that was in flight, right? As a sort of protection to this attack to some degree. So this accounting change will allow non-SAC to also use PRR very easily and doesn't really require any extra state. Next slide, please. Other minor issue, the original RC does not try to force fast retransmit upon entering the recovery. For example, in the original algorithm, that you have a sendCount state variable to decide how many packets you are allowed to send for the given act that you just processed. And it's possible it's 0 because you want to make sure it's proportionally the rate is according to the new SS stretch, whatever the sort of guiding congestion control says that what the new window should be. This has an obvious downside is that you could potentially lose act clock because you don't know if there's gonna be more act coming, right? What if there's only one packet that survived this storm? So here we added this, will force a fast retransmit only once during recovery, and that fast retransmit is also accounted in the out delivery packet. So the algorithm just make a little bit tweak, but force one out to keep the act clock going. This was originally implemented by Linux. It just didn't get documented in the RC. So we put it in there. Another one is like the original RC didn't even define how do you calculate the C-win. And here we define it like it's simply the in-flight or the pipe plus the sendCount state variable. So that with this C-win calculation, you would send exactly the sendCount number of packets out to make it more clear. Next slide, please. Other minor edits, we also recommend that you should use rack TOP so that, remember we talked about we want to make the algorithm more dynamic and we want to say, hey, does this act indicate further losses? That usually means, is this some fast returns that also get lost again? In that, you do need the rack TOP to detect that properly. We use recommended because there could be other techniques to detect that. Rack TOP is only one better detection algorithm. And remove some deprecated rate having text and the experiment section, since now the experiment have been concluded, and update the examples to reflect the new algorithm. We also noticed that Linux had a bug that was reported by Bob. Thank you, Bob, about the original implementation. So we also send a Linux patch to fix that. So that's all for my presentation. I hope that we can maybe discuss if we should move to sort of conclude this bit revision so that we can turn the experimental RC into standard. Okay, thank you.
Thank you for the presentation. Any comments? Yoshi.
Hello. So I think I sent some kind of review comment on the mailing list a couple of months ago, and it seems the new version seems to be address some of my comment, but if you could respond to my review email, then this point you guys updated, or this kind, it's not necessary to update, and so on. If you could do that, that would be very helpful for me.
Sure. I think I went through all your comments and I believe I have addressed all of them, but I'll reply it explicitly to your email to show which part I changed in the draft. Yeah, to address your comments. Yeah.
Richard.
So this is Richard. Just wanted to say that I'm very happy that this now finally seems to be progressing again. I would want this to become going through a working group last call quite rather quickly, having implemented the PRR on the old draft, and I would like to improve especially the heuristics, but would want also to have the proper RFC at the time so that it can be made upstream, right? Thanks.
I think Gori left the queue, hopefully intentionally. Any other comments? Then thank you, and follow up on the email with Yoshi.
Will do. Thank you.
Okay. I think the next speaker is Bob. Bob, are you running your slides?
He wants you to run the slides since you probably didn't hear that.
Thank you. I didn't hear that.
Oh, yeah. Right. Next slide, please, Michael. Right, a very quick recap. Accurate ECN is a change to the TCP wire protocol to deal with the problem that the existing ECN feedback is only for congestion controls that need only one feedback per round, whether or not there's more congestion than that. And it involves two pieces. A small 3-bit field that is essential, and a supplementary option. And having this feedback gives you the fine-grained control that allows you to reduce delay a lot more. We're using NL4S, but it's got other uses as well. Thank you. Next. So since the last cycle of within the last cycle of the IETF, there's been 2 updates. Links there on if you go to the slide for the 2 diffs, and also an English summary of the diffs on the list. In response to requests from Gori, from ILPO again, or a follow-on to ILPO, the change to ILPO, and finally, some work that was happening earlier in the week on the interop. We found we hadn't properly documented the experimental IDs of the TCP options, and 2 different implementers had guessed 2 different numbers. So you'll see we've sorted that. Next slide. So firstly, Gori wasn't happy with the section on ACK filtering, which updated RFC 3449, which is, as the little asterisk says at the bottom, TCP performance implications of network path asymmetry. And it particularly updated the ACK filtering part of that RFC. And Gori pointed out, and he was right, that that RFC referred to 3168. And so because Accurate ECN says it is going to update 3168, that RFC will then apply to Accurate ECN as well. So we don't need to specifically update it. It just automatically happens by updating RFC 3168. So we changed things around. And we added a bit more technical detail on how to do it, how an ACK filtering node might handle Accurate ECN feedback if it was trying to improve performance, which is the whole point of ACK filtering nodes. Okay, any questions on that? Move on. So the second change after ILPO had implemented this, he said the implementation for sending the TCP option, the Accurate ECN TCP option, was
much simpler than the receiving side of it. And so the previous recommendation in the draft was that you're recommended to at least do the receiving side, even if you don't do the sending side. Obviously, you're recommended to do both, but if you're trying to start out, do the receiving side first. And so we switched that to be do the sending side first, because that's the easier side. And that means that anyone that does do the receiving side, if they're getting this option arriving at them, then they sort of can unilaterally get it working by just implementing the receiver side. This means the receiving of the option, not the data receiver, because it's the option is feedback, so it's the opposite half connection to the data direction. Okay, and this cycle in draft 20, we just added a little more strength to the recommendation as to why it's important to implement this, and you'll see the green text there says that. I won't read it out. Any comments on that would have been on the list. It's had I think a week. So there's one little point there that because ILPO has implemented both send and receive logic in Linux, if that does go through to the main line, then most Linux servers will be able to handle both sender and receiver, which is another argument for if you're a client receiver and you don't really want to bother implementing this, at least if you do the sending side, then the server will be getting feedback on the downstream at least. Okay, next. Right, this is the point about us omitting to register the experimental IDs that we've been using for this TCP option in implementations. Retrospectively registered them, or Richard did earlier this week. They're now as of Wednesday evening, I think, they were on the IANA registry, as shown there. But then what we want to do now is go for an early registration, no, early assignment, I think it's called, of the actual IDs that we want to use while this is in parallel to this going through the working group last call process and so on, so that the implementations can start using the real thing. Next. And the next is the next step slide. We have a one early security area review that ends up showing has issues, but it was all resolved, and the author of that review has agreed it would be almost ready if he put that status in again. So I believe we're ready for a working group last call. I don't think there's anything else I've seen on the list. Anyone wanting anything done? And well, the authors are all happy that everything is done that should be done. So I don't know whether we're going to do that here now. I just wanted to also add the other 2 points there. We're going to, I don't know whether we need, or the chairs need, a feel from the room whether we should go for an early assignment as well. And finally, whether generalized ECN, I mean, that's been ready for working group last call for some time. Whether we go for actually doing that, but it has a dependency on accurate ECN.
Martin Duke, Google. Yeah, like early allocation, I think is a good idea, because if it turns out that whatever we allocate gets eaten in the internet, that would be good to know before we published, before it goes to the RCN. And I don't know if they're magic, like unallocated options that would make it through the internet or not, but you know, who knows. I did have a question. You said you implemented for Linux, and I'm wondering if you reached out to the Linux kernel maintainers about accepting any of this, in particular, at least the receive side.
Well, the reason this issue came up is Neil was testing his Linux implementation with interop with Richard's FreeBSD implementation at the Interop earlier in the week. So yes, Neil is the guy that.
But I'm saying, but he's not a kernel maintainer. Like the actual like Linux mainline, it would be great if the sending of the option was in the kernel, because then, you know, commodity Linux servers would do the right thing.
Well, I mean, when Ilpo's original patches, he produced a patch set for the NetDev community, and basically it was all ready. There weren't any problems, but waiting for the IETF to do the RFC.
Okay.
And I mean, Neil is one of the people. The Linux community tends to work on trust, you know, and Neil is one of the people that would be a name against that. I think I'm not presuming that Neil will say it's okay or anything, but you know, that's up to Neil. But you know.
All right. Well, I'll ask Neil how that's going some other time. Then thanks.
Yeah.
Quick question: is the Linux community waiting for the RFC or waiting for the option kind assignments?
You'd have to ask them. Sorry, but when we originally put it in, it was waiting for the IETF approval. It wasn't clear whether, like, if it got through working group last call or if it got approved by the AISG, or whether it would actually have to, you know, be a published RFC. I don't know at what point they would be happy, but we can find that out.
Okay, you too.
Yeah, a couple of things. I think we definitely should get a real option ID as early as possible, and don't use the experimental ID in implementation. This is based on a real my own experience with Fast Open, because if you have both, then you need someone to upgrade the ID. Right, when there is a server that only talks the experiment and the other one that talks both, right? So it's a pain. Another one is for the generalized ECN. A quick comment is that is it possible to make that generalized ECN, since it's generalized ECN, also good for the DC-TCP cases, because we don't expect people that use DC-TCP ECN will hop on this accurate ECN anytime soon, right? Because there's a real implementation block, right? So that's my question.
Yeah, that's a good point. We can. I have to think how we would word that, but because we have to be careful that we don't sort of endorse using DC-TCP over the internet somehow. But well. We should be able to do that, yeah.
So this is Richard. I'm just to the comment around generalized ECN for data center TCP. I have a private patch to do this exactly because of the same reason that AQM that is compatible with L4S would mostly be compatible with data center TCP as well, and therefore generalized ECN and data center TCP would, in my opinion, be a natural fit. However, we need to progress on that draft in order for this actual implementations to progress. Thanks.
Yu-Chang, do you want to? No. Okay. So I just wanted to add that the DC-TCP implementation in Linux already does what generalized ECN says. It just sets ECT on all packets. It doesn't not set it on SYNs and ACKs and things like that. I think Yu-Chang was just asking for that to be endorsed by the RFC.
Okay, I'm not aware of that, but we can confirm that offline since it's just implementation specific issues. Yeah.
Could I ask Martin what the procedure of early assignment is? I mean, how does it work? Who decides which part?
I think I have to like give my approval, but I think you could just send an email to Ayana. Do you remember?
So you will, assuming you will, You will approve that, and then Ayana will execute that, or is Ayana discussing that, or?
Is it through the secretariat or through Ayana that you do early allocations first? Who's the first contact? Yeah, just email Ayana and CC me, and things will move forward, and we'll figure it out from there. Do you have the answer to this?
I'm being an Austrian, so I started the process early on an informal basis.
Can you get close to the mic?
Sorry, I'm Richard. I'm from Austria, so I've started this process on an informal basis. Jana is aware that this is going on, and quite frankly, the process, as far as I understood, is that the formal request has to come from the chairs of this group after the group has agreed. The AD has to basically sign it off, and as soon as that is gone, just send the email with those approvals to Jana, and they will do it.
Yeah, I would just send an email, CC me, and I'll just reply, I approve, and we'll be good to go.
Okay, we'll discuss this within the chairs.
One question, Bob. So I think the draft is mostly ready for working group Rust from my point of view, but I sometimes exchange email with you and Gori about some editorial things. I just would like to check if already settled down, and you think you are ready for working group Rascal.
Sorry, did you say that? Are you saying that there's some emails we've missed, or?
Yeah, I think so. I'd like to confirm discussion is still going on, or it's finished.
I think discussion's finished, but if you point me to anything that I've missed or anything, then yeah.
No, I don't think so. I just
Okay,
like to
yeah.
confirm.
I can confirm that now, and I can confirm it by email as well if you want. Yeah.
Okay. Yeah. And then another thing is, you want to wait for early assignment for working group Rust-Go, or you?
No, I think the two can go in parallel because I don't think either needs to depend on the other. Yeah.
Right.
Yeah.
Richard? Richard, do you want to be in the queue, or did you forget to exit? Okay, Yuchun.
Yuchun?
Yu-Chung, you're ahead of the queue. Do you have something to
Sorry.
say? Or you just, okay.
Couldn't release the mic button. Yeah, I just want to double check that we accurate ECN is now have a working implementation that can show it works with GRO and TSO without any issues. Like if we just run it now, say inside data centers, right? The TSO, GRO will all work fine. No fine prints. Yeah.
I believe it does, and I believe it. This is Bob. Sorry, I believe it does, and I believe it should. But yes, obviously, test it yourself is the answer to that question. But yeah, the code should work like that. Yep.
Okay. So that has been my most concern of accuracy. Yeah. But if that's clear, then I'm happy to support that. Yeah.
Gori?
Gori Fairhurst. I'm just responding that I think Bob solved the issues we discussed, so I don't have more issues on that one.
Thank you. Mia?
Yeah, I just wanted to follow up on Yuchun's questions about offload support. I guess the one big question I remember was this question of whether various network devices in their TSO transmission offload facilities might do the wrong thing with the ACE bits, since they don't know that they're trying to be used as ACE bits and might interpret them as other TCP flag bits. Is there anyone who can sort of quickly summarize where we are with this question of NIC compatibility within the ACE field?
I can summarize that when TSO and GSO or GSO is done in The Linux stack, that's all handled. With hardware, we haven't had those discussions yet. We sort of need the community that, like yourselves, to, so that we can start those discussions.
Any other questions? So the early assignment stuff we'll discuss between the chairs and then send the appropriate mail. Thank you. So now it becomes interesting. Is Mahesh able to give a presentation now? So he is not on site, he is in the train, or maybe not anymore. So he dropped me a note that he might be just out of the train, heading to the hotel. Mahesh, are you there? Oh yeah. Do you want to run your slides? It's very hard to hear you. Can you say something?
I think you are muted.
No, he's not muted. I can hear him, but it's very, very silent.
It's so quiet that I can't hear him at all.
Well, I can, but so he's not muted completely, but. Yeah, that's now better.
Okay, can you hear me now?
Yes. So I think you can start. No, that's worse again. Whenever you use your earphones, we can even hear a bit of the music.
Okay, I don't know if this is any better.
Yes, it is. Just start presenting.
Okay. All right, sorry for that snafu. I'm in a public place, so do not mind the noise behind me. I'm here to give an update on the TCP Yang model. So we started the scope of this Yang model for TCP with a fairly narrow scope of providing basic statistics, which by definition were optional to implement, a list of TCP connections, and a newly added list of listeners for that was added in the recent version. That definition of that listener list was established by what is existing in TCPM. The third item there is the modifications to support TCP/AO and MD5. Previously, we were trying to implement by not augmenting the keychain model, and that didn't go down very well. So the recent changes now add the augmentation of the keychain model to support TCP/AO and MD5. The final addition was the import of keep alive groupings from Netcom TCP client server draft, and this is mostly for alignment between the two documents. The current status of the document is it's in ISG evaluation. There is a revised ID needed currently to address 3 discusses and several comments that were received. And the authors are working on an updated ID, which will post right after the holidays. No fundamental extensions of the scope of the model are planned as of this time, but some minor edits will be required to address all the discussed comments. Now, if I can only move to the next slide. All right. So here's the overview of the ISG feedback. We have got, as I said, 3 discusses and several comments. A lot of them have been addressed in a working copy that you can see the status on the right side. A lot of the discusses and comments were related to the encoding of any in the TCP listener list. And I think that does need some minor changes that we'll be working on. The other was the new addition to support TCP AO and MD5 and the corresponding examples that we have in the draft. There were some inconsistencies in that example that we have tried to now address. And then some inconsistency in the 2119 language we have also addressed. There was a suggestion to remove MD5 support, which the authors are not planning to, because we do have a requirement from the BGP Yang model for support of MD5. Anyway, the status of all these and the changes is being tracked in the GitHub location link at the bottom of the slide. So as far as the encoding of the any listener list is concerned, it's currently encoded as a union that you see, the definition of which you see below. And this definition comes from the TCP MIP. And I think the question or the discussed comment that we received was, how is the IPv4 address of all zeros or the IPv6 address interpreted by this particular union? And the Yang 1.1 language essentially says that if in a union you have 2 type definitions, you're supposed to parse the types in that particular order. So if it interprets what it has received as a string, it will assign it to a type string. But in this case, if the type is actually a value of 4 octets of all zeros, then it will be assigned the type of INET IP address. And we'll try to clarify that in the next version of the draft. The final slide, as I mentioned, the AO configuration and examples, there were a couple of suggestions on how to make the containers for AO and MD5 presence containers, which we have adopted in the draft. It's a minor change, doesn't fundamentally change the model in any way. What is new and a required addition is that because TCP AO supports AES 128, and the example in the draft did not reflect the fact that the crypto type that AO supports only AES 128, we needed to add that to the draft. So after adding that, we had to update the examples to align it with RFC 9235 also. I think that's pretty much all I had from an update perspective.
Thank you very much for the comments, for the presentation, and for arranging that you can make the presentation.
That's sheer stroke of luck.
Are there any comments? I only have one, which means you said you changed the examples. Are you able to check the examples that they still work, or
Yeah, so as part of the draft, we do run the example against the model, and we use Yang lint to do the verification that the example does correspond to the model.
Okay. Are there any other questions? If that's not the case, then thank you for the presentation. And this presentation was kind of a foundation to the next one given by Guyan on what might be missing. So, are you there? Yeah. Are you running the slides locally, or should I run them for you? Okay.
Oh.
I understood. Thank you, Martin.
Hi, my name's.
Hello.
My name is Guillaume Mishra with Verizon, and I'm will be presenting the next-gen TCP Yang model, discussion that came up through the Opster review recently. Next slide. So here's some motivation and some history related to the next-gen TCP Yang model. So during the OPSEC review of the TCP Yang model that was just discussed, as a result, we started looking at a possible next-gen TCP Yang model, and would like to get feedback from the Tcpm working group as well on this, on thoughts regarding this process and if it's something that's feasible. So as a result, we discussed the Yang model and what would actually go into it on the mailing list. So Yang is about visibility similar to the SNMP MIB and not remote management. Just some discussion that we've had that the current Yang kind of really mirrors the SNMP MIB. And from the routing area grouping, kind of what we were interested related to the next-gen TCP management, TCP Yang model. So it's not really necessarily remote management, but what we would like to be able to do is observe the TCP parameters related to the TCP session state and telemetry, either back to a controller or a netconf/Yang, just being able to pull statistics. We would like to be able to see everything that could be seen if you're looking at like a local, like an OS hook into the kernel, just visibility into a TCP parameters related to the connection state. Next slide. So the motivation here on the TCP Yang model and reasons why. So I would say the main use case that's really related to BGP. BGP has over the years has expanded its scope. One of them is related to data centers, massively scalable data centers, and which is BGP only now with RFC 7938, and that's something that a lot of operators are looking towards. So kind of really the visibility and the need for stability with BGP and being able to have monitoring capabilities related to BGP is really, really important for operators. Next slide. So this is a just a use case that came up. It's come up a few times in the IDR working group, and it's related to internet outages that have occurred with the TCP window going into collapsing and having a zero window resulting in a stuck state. And I just put in there the mailing list archives related to that discussion. So in this state, what ends up happening is you have like a route array on the left that the control plane is congested. He's got a send window greater than 0, but then he's got a receive window of 0. And then router B, he's uncongested. He's got a send window of 0, but a receive window greater than 0. And then the router A, he's not able to write to his TCP buffer. So even though the router B sends like a log message notification back towards A is congested, and the session ends up staying up. So we're not able to reroute traffic, and so which results in a internet outage. Next slide. The second use case is related to compute nodes in a TCP session, just being able to monitor statistics related to the session state, and then windowing and the window scaling, and then mostly for throughput and application traffic, I guess server to server or client server, I guess response time. Next slide. So I guess really the big question is that what do we want to add to this next gen TCP Yang model? So just in summary, I just threw in just some bullets of what we're thinking. One is all the TCP states that are part of the FSM state machine, TCP flags in respective states, TCP parameters that would be accessible through the local kernel, windowing parameters, TCP options and optimizations, and then the CWIN TCP congestion control, so the CC parameters. Next slide. And so I'd like to get feedback from the TCP working group, just thoughts related to this. Thank you.
Michael, did you just say, Bob? I think I read your lips, but you're muted, I think. Yep.
You can read my lips correctly.
Just to point out, all TCP options is probably excessive, because probably I don't know how we make a list of those that are actually used, but there's a lot that aren't. So
understood.
Yep.
Maybe parsing through, because I'm not really, if I don't know what how large the list is, but probably parsing the list and see what would be pertinent, I guess would make sense. Because I'm sure if it's a lengthy, probably doesn't make sense every single one, but just finding the ones that are pertinent, that would make sense.
Martin Duke, Google. Can you go back to the use case 1?
Sure.
So I'm a little confused by the example. So you have keep going, Michael. It's just taking
Which
a long
one was
time.
it?
That one.
That's it.
Okay. So in this case, like from A to B, both the send and receive windows are non-zero, so data can be sent. And then
right.
in B to A, it's like both sides are deadlocked, right?
Right.
So like what is the cause of this situation? I mean, is this just a question where like we just need to wait for an ACK from B to get A unclogged, or like?
Yeah, so what ended up happening in this stage, so the router A, he's not able to I guess he's the one that's kind of has its management plane it's hung.
Okay.
And so his since the management plane uses TCP as well as BGP using TCP, he's not able to like to write to the I believe it's the receive window. So he's not able to write to his buffer, and so he is not able to process, I guess, anything. Like even if he gets the message, what ends up happening, he just doesn't close the session. I think that's the thing. He's not aware of the other end. He thinks everything is still up, and he keeps the session. Like I think the best thing that would happen is if somehow he was able to like close the session or do a TCP reset, and then traffic would converge to an alternate path, but the session just kind of it ends up just staying in an up state. So that's where I think in like if like a client server application where you have, TCP 0 window, which happens, and then the window opens up. In this particular case, because it's router to router, when that happens, that congested state happens, it's like the management plane is just completely hung. But then the BGP just because the management plane is hung and it's using TCP, the state of the connection ends up remaining active, and unfortunately BGP doesn't reroute.
Okay, so the problem here is A is hung and B doesn't realize that A is hung. Okay,
right. That's right.
But like your remedy is to reboot A, then I would imagine.
It is, but I think what ends up happening, I think with the NOC, whenever this has happened, because the session is up, it's hard for the NOC to realize that it's because it sees routes and everything seems like normal, but it's not able to process anything, so it takes time.
So the issue. So I'm guessing that in this scenario, A is not reporting Yang stuff because it's toast. So it's B is. So what you're trying to do here is use B to ascertain the state of A by looking at the TCP parameters.
Right.
Okay.
Exactly.
All right. That at least makes sense. And just to be clear, these are not like commodity TCP implementations. These are specific to the routers they have their own distinct TCP implementation.
Yes, probably. Yes.
Okay.
Different vendors, I guess.
Or I mean, because I'm just saying, like, if you're just using Linux TCP, I don't know that you can I mean, I doubt they're going to implement the Yang, and so there's no market for this if that's the case. Yeah, I mean, I'm a little like, it seems like you're not like tuning since you stated you were not tuning these parameters.
Right.
I do. It seems like your actual option is just like reset connections, reboot stuff.
Right.
And like, I'm wondering if a much simpler like I am deadlocked model is much simpler than trying to like have like dozens and dozens of parameters that you're specifying and reporting and like having complex logic for what means what. Just having looked at this and thought about it for 10 minutes. But thanks. I think I understand your use case better now.
Thank you.
Regarding this deadlock situation, I'm wondering, I mean, the TCP connection can be up and happy even if you are not able to progress user data. So if the application is stuck from a TCP point of view, that's fine. So normally what you do there is application layer heart beating or application layer test messages, and then you figure out that your peer application, you can't talk to your peer application layer anymore. But on these points, I'm trying to. So I don't know much about Yang, so that's why I want to figure out what you are looking for. Looking at TCP flags, this means like you want to do kind of a live tracing of which packets are being sent and received. And reading that you want, where is it state? You want to, all TCP parameters that will be accessible with a local OS kernel hook. This looks like a lot of implementation specific values. And I think it's very hard to standardize them. So my understanding is that you can get a snapshot of a state, but like continuous monitoring seems to be different.
That's correct.
As far as the TCP parameters, I think someone else had asked that question, but I think really maybe the pertinent parameters. I don't think we'd probably need all of the parameters, but I think what's pertinent to the connection state that actually would help us in determining whether a problem, I guess for like the NOC, I guess if there's a problem and maybe parsing through the parameters, and there may be some key parameters that would be helpful, I guess. So
I mean, do you want to know that timestamps have been negotiated, SEC has been negotiated, and window scaling? These are the typical TCP options which are negotiated.
Right.
In your case, I guess TCP AO or TCP MD5 also, but that's a static thing. That's something you can query and get a response. But I don't see how that helps in the problem you showed. Jeffrey?
Jeffrey Haas, Juniper Networks, BGP developer, Yang author. So you gave me a giant list to try to work through. I wish I could have hit them one at a time. Sorry. So to Guyan's point, the stuff that's in here state-wise is all appropriate. Your point about we're not trying to implement TCP dump on top of Yang. That does not make sense. So being able to look at the TCP flags, modeling all of those, that's not a big deal for the session. If you think about most TCP stacks, you're setting these things as socket options, and that's an appropriate thing to see as part of socket state as an example. There may be appropriate things like, if you've seen an unexpected TCP option on the session, you could also record that and basically say, this was a thing that's seen. But trying to snapshot live state for flag for each packet is not part of the goal. So rolling back to the use case one stuff, with the stuck sessions, there's multiple reasons this stuff can happen. Sometimes you have drop packets at inopportune times where each side sort of thinks that it's trying to get out of the state and it just never gets there for some reason. Sometimes you have that due to specific types of network drop. Sometimes authentication can cause that in certain circumstances. But in the vast majority of cases, these things are either bugs or other unusual circumstances that the whole issue is this session is wedged. The client, BGP as the example case, but this can happen for other things, is sort of stuck waiting to get out of the circumstance. And if you're not implementing a form of protocol, keep alive or hold timer that expects to get out of the situation, because as far as each side can tell, you have data pending. You're waiting to actually move along. So the challenge comes, when you get into these stuck situations, how do you troubleshoot them? And if you're on the box, you're going to sit down, type netstat, and see what's going on. What's needed for operators that are trying to troubleshoot applications like BGP that are used in routers to be able to troubleshoot the situation remotely is being able to just simply get the status of the session, see what's going on, and there may be opportunities for some level of telemetry for these stuck situations, like zero windowing is a common thing. You don't want to generate a Yang notification or trap out of this sort of thing, just like you wouldn't want to do an SNMP. But it's very appropriate that if you're monitoring these things and you see that a BGP session sort of gotten stuck, being able to query, via netconf, what is the status of the socket? It's been zero windowed, and if I see that's been that way for a minute, you can then take action, like resetting the session, using your router protocol. So there's a lot of options for things that you can do here, but most of this is the same type of visibility you'd get via CLI, and just simply putting it into the management plane in a generic fashion. And there's a throwaway comment about modern stacks. We run BSD drive stacks, we run Linux drive stacks, and we layer stuff on top of all that for management. So this is not an unusual thing.
Thank you.
Thank you, Jeff. Thank you, Jeff.
Quick question, Ken.
Yes.
So are you going to propose a new document?
Sorry. So I want to generally reflect, I think, the comments that both Jeff and Michael provided, both as author of the BGP Yang model and the TCP Yang model, that I think trying to keep track of state information, or at least the live state information, probably doesn't make sense as a replacement for TCP dump. But definitely for conditions, just like Jeff pointed out about stuck connections and zero window, that certainly can be a helpful piece of information that we could add to the model.
Yeah, that would be perfect. I mean, that's really, as Jeff described, that's exactly what we're looking for. Somehow that we can get an alert, when that stuck state happens with the zero, when that zero window happens, and being able to, get a report, flagged, I guess, to the NOC, and then being able to, act on it as soon as the stuck state. Like if it's stuck for a period of time, then we can act on it and reset the session.
Martin Duke, Google again. So like, obviously the BGP community uses Yang, and so we're doing Yang work now for them, and I think doing more work for them is fine. I just think, I think the principle we're trying to apply to our Yang work is to not try to do all of TCP, because the MIB experience was a terrible one, and to be very, very deliberate in adding stuff to that. So like, if this work, I don't fundamentally object to this work progressing, but I would like to the proponents to think hard about what kind of information would be actionable, and whether you need like really fine-grained stuff like window sizes, or like where like Booleans could be used, or like if there's a bunch of stuff where the answer is reboot the box, like just have like a I need to be rebooted indicator or whatever. Off the top of my head, I'm probably not saying that right, but to not have try to have a very like small Yang model if possible that covers what you really need for these use cases, and that that relates to actionable stuff, and that will just make this a much more tractable thing to get through the process.
Makes sense.
Jeffrey Haas following up. I don't disagree with you. You want to keep the model as small as reasonable. Yang has the property that it can be extended, especially proprietary, in a very easy manner. Offering advice to this working group, having done a lot of Yang stuff for IETF at the moment, you have a choice in front of you. You can either do enough of the work such that everybody that wants to use the stuff, and leave a lot of stuff optional, and model it once, or risk all the vendors coming out and saying you missed an important thing, and every one of them doing a proprietary extension and forking everything. So it's a hard walk to do, but it's doable. Thank you.
Thank you, Jeff. All right.
Yoshi, didn't you want to ask a question?
Does anyone have any other questions? Okay. All right. Thank you.
Okay. Any comments regarding the Yang stuff? If that's not the case, then we are at the last presentation, charts.
Okay, hello. Can you hear me?
Yep. Are you running your slides?
Or can you do it? Or...
I can do it. You can do it on your own. You have on your upper, so below your name, the second item from the left.
Yeah,
you can choose your slides.
Slides requested. So I pressed ask to share. Yeah, okay. Now I see the slides.
Then you control them yourself.
Okay. Okay, so hello everyone. My name is Carlos Gomez, and I'm going to present the updated version of the draft entitled TCP Accurate Request tar option. My co-author is John Crook from the University of Cambridge. So first of all, let's take a look at the motivation for this draft. Delayed ACKs is a widely used mechanism which is intended to reduce protocol overhead. However, it may also contribute to suboptimal performance in some cases. For example, in so-called large congestion window scenarios, meaning congestion window size much greater than the MSS, where saving up to 1 of every 2 ACKs may be insufficient. For example, when there are performance limitations due to asymmetric path capacity, or when we want to reduce further the computational cost and network load. And then there are also so-called small congestion window scenarios, that is congestion window size up to the order of 1 MSS. For example, in data centers where the bandwidth delay product can be up to the order of 1 MSS. In this case, delayed ACKs will incur a delay much greater than the RTT. And also when there are transactional data exchanges or when congestion window decreases, then yeah, the ability of requesting immediate acts may help avoid idle times, or it may allow a faster congestion window growth. So on the status of this draft, before the creation of the document, there was some related prior discussion in the area of sender control of TCP acts, which appeared to converge to defining a new TCP option serving two purposes: the ability of requesting a given act rate and the ability of requesting immediate acts. So since the last IETF, we produced versions 04 and 05 with the aim to address comments received in the last IETF and also on the mailing list. And by the way, thanks a lot to everyone for the useful, very useful feedback received. So now let's go through the updates in the last versions of the draft. So here on the slide, you can see the main format of the option. You have the old version, which is -03, and also the new format in 05. So there are several things to mention here. First is that in previous versions of the draft, there was a feature called ignore order. However, it was not very clear whether this was actually useful. We received a significant amount of feedback in this regard, so we decided to remove it from the document. A second point is that now in 05, we state that the kind field value is 254. As you may recall, the intended status for this document is experimental. So we are following RFC 6994, which defines the shared use of experimental TCP options. And according to that RFC, the kind field can take only two values, 253 or 254, so we have chosen the latter. And the last comment for this slide is that, well, it was mentioned on the mailing list that the old format having an odd length, in some cases the implementations might, or implementers might want to add some padding to make the size even. So based on that, we decided to make the size even by ourselves by extending the size of the option by 1 byte. So this is by increasing the size of the R field, which carries the requested ACK rate, and also adding a few more reserved bits for future purposes. So regarding the R field, as you may recall, in version 03 of the draft, we were considering two different options for encoding the R value. The option one was using a simple binary encoding, where the maximum value of R was 63. Then there was option two, which was a bit more complex with an mantissa, an exponent, and a possible maximum value of 1024. So now in 05, making use of the additional bits, now we state that the R field carries the binary encoding of the ACK rate. Then we also state that R equal to 0 is a special case where we request, the sender requests an immediate ACK, while not modifying the default or steady state ACK rate. And with this encoding, now the maximum value of R is actually 2047, at least in version 05. So there has actually been discussion already in the past regarding the maximum value for this parameter, the requested ACK rate, R. So again, in 05, it is 2047. This perhaps is for discussion. But, well, in the past, there have been questions on why values greater than 63 would be needed. So there have already been some answers given. For example, Jonathan wrote a nice and detailed explanation of why there are some values for R in the range of 100, few hundreds, or even 1,000, which could be even justifiable in current scenarios. For example, assuming a link rate of 1 gigabit per second, RTT is up to the order of 100 milliseconds. Those large values for R would still comply with a sort of rule of thumb of having at least 4 ACKs per RTT. And then there have also been comments, for example, by Bob or Juhamati, expressing that it would be nice to make sure that that our option could be useful as well in future scenarios where the expectation is that there will be even greater link rates. So I don't know if there are any comments on this maximum value of R. If not, yeah, I think there's Gori in the queue.
Oh. Yeah, I'm going to argue that flexibility here isn't a good thing. That having one ACK every 100 packets is still pretty infrequent. We've used it with RTP and other protocols. It's not a big overhead. Why would we ever want to go to 1,000, even on gigabit links? One ACK every 100 data packets is a very low load in rate or volume.
Okay, so yeah, I understand, for example, some of the reasons expressed for larger maximum values in that order would be to reduce, for example, the amount of ACKs that would need to be processed by the network. But also I understand the concern for large values of R. So yeah, I guess, and I'm wondering how to achieve a suitable trade-off here.
Hi, this is Bob Briscoe. I've just discovered that a mail I thought I'd sent, I never sent, so I'll say it now. Obviously, I didn't click send, and it's sitting in my drafts. I noticed that the format of this has now become very close to the ACK congestion control RFC that we already have, which is just basically an 8-bit number. And the rules as to when you can send that are very similar. So I don't like to sort of point this out, but maybe we've converged on something where you don't need to do anything anymore, Charles. we already have an RFC, and we can just use it. That gives you 8 bits, so it's 256 as your number. Just think about it. I should have sent this. I'm really sorry. I should have sent that mail earlier, but just see whether there's stuff in that RFC that precludes the use cases you're thinking of, and maybe it's an update to the RFC that's needed or whatever.
Okay, so I guess if you can send the message you had prepared with possibly the details, I think it will be very helpful.
Probably got some old stuff in it because it was in answer to something from Jonathan Morton, but that was just a side comment. So I'll send it. I'll press send, but I'll put a little note on saying some of this might be out of date.
Thank you. Okay, so yeah.
Hello, Yoshinichi. Just personal opinion. If we want to save the option space, even just 1 byte, maybe we can use the previous version. And if we need big value, and we can utilize reservation bit and then allocate new formats, something like that. Then maybe we can address your concern.
Okay, I see that yeah, there's some pressure on one hand to maybe have an even length for the option, but then also may want to keep the format short. So yeah, let's see if we can find a suitable solution.
As an individual, at least looking at the TCP options we are using right now, they all have an even length. So that's why, are we really saving a byte if we have one option with an odd length? That was my point in suggesting, if that's not the case, then we can just use 2, because you will pad it anyway.
Okay.
Richard?
So while we are generally doing padding, padding is something that we could really do away with. I would really more like to see an argument made that larger field length or option length is really valuable. And as Gori just pointed out, even a value of 100 is already quite excessive, at least at this day and age. Having a transport protocol flying without feedback for thousands of a flight of thousands of packets, I can hardly imagine a transport protocol that would, have a decent properties with such a rare feedback. On the other hand, I mean, this is advisory and not a mandatory option, so the receiver can use it, can delay, but it's not that it has to follow that. So therefore, that's the other thing, the other aspect. I don't think that we need really that lengthy option. Thank you.
Regarding the option, the concatenation of all TCP options has to be a length divisible by 4. So that's the padding I was referring to. By the way, I closed the queue since we are at the end of the time, and Carl says there's still a slide. Jonathan.
So there's a question about whether a large value of R is harmful, and that's why we have the rule of thumb of having 4x per RTT, because that gives sufficiently rapid feedback to suit the network path. It's also worth remembering that if a congestion event occurs, that will result in an immediate feedback, regardless of the value of the delayed act timer.
Carl, do you want to have show more slides, or are you basically done?
Well, perhaps just one, which is super quick.
Then do that, because we are running already over time.
Yeah, so just mentioning that, we have running code, so this is great news. And as Michael announced on the mailing list, he has been leading the development of a prototype implementation of the draft for FreeBSD. My understanding is that there are some features already supported, and it will be completed in the next few months. So that's it.
So it's basically, it was a student's project to get this implemented, and there will be some final touches before it can be open sourced. Any other comments? If that's not the case, then thank you.
Thank you.
Yoshi, Ian, do you want to say last words from Philadelphia?
See you in London.
Yep. See you in London.
See you in London. Bye.